So I want the common name of this for this molecule here. I have a lot of questions here. Oh my god. Okay, so there's like 5 questions here I have to figure out. So in this case here, the solution does give us the 5, so I guess we'll do the 5. I usually don't like actually doing like, I don't like it when people submit more than one kind of question per kind of question here, because this is like a 5 questions. I could have actually done like 5 separate questions with these guys here, but I'll try to, maybe in this case, I'm going to just kind of speed through it, look at the solution and tell you the answer. But yeah, I guess I'll do the first couple here. So I want the common name and the systematic and iupac name for the molecule, right? So I have CH3, CH2, 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 2, 3, 4, and then this is bonded to SH2. I want the iupac name, right? So again, if I'm figuring out using my iupac chain, I have some type of, this here is a sulfur group here, and then I'm gonna count my carbons. I have 1, 2, 3, 4, and 5. So my the ending of my name here is pentane, right? Pentane. And then this group here is I have a thiol group here, right? So, or I can say here this is a pentane thiol, and this here will be my kind of iupac name for this for number 6 here. And as you can see, it's pentane thiol here, which is good as well. So this here is the iupac name here, pentane thiol, and you could write a 1 here if you wanted to state that this thiol group is on carbon 1. That's up to you. And the common name here is pentyl mercaptan. I don't know how I'm gonna pronounce that, but that's the common name. I don't think you're not supposed to really know common names here. As long as you know the iupac name, I think it's fine here. So number 1 here is correct. B here, or this is, I guess, 6A and B. So C is asking us dimethyl sulfide, draw the structure of dimethyl sulfide. So again, I have an S here. It's going to be my sulfur atom, and I have 2 methyls attached to dimethyl sulfide. So you can think of this as here, as this here is H3C, this here is CH3. There's 2 methyls, dimethyl, and I have a sulfide atom here. So this is dimethyl sulfide. And again, this here is the correct solution as well. You could have written the lone pairs like this person did as well, which is actually makes it more accurate, which I kind of like here. So this is a great solution as well. D is asking us, if a solid line represents a covalent bond and a dotted line represents an intermolecular attraction, which of these choices show a hydrogen bond? So again, hydrogen bonding only exists with 3 compounds. So I'm going to say H bonding with 3 elements here. This is N, O, or F here. And as you can see, the first one here, I have this dotted line with C and H here. This is not correct because again, C is not, I don't have a hydrogen bond with carbon. This B option here is correct, right? I have this hydrogen here is hydrogen bonded to oxygen here. So this here is valid. And let's see. This here is bonded to itself. So therefore, this is not hydrogen bonding, but this here is just simply a covalent bond, which is good. And B here is asking, or D here is I have this N here. It's hydrogen bonded to this hydrogen here. So this is actually an example of hydrogen bonding as well. So this last one here is also included, which I stated correctly, which is good. So that solution is correct. And finally, these 2 guys here is asking us, select the atoms that can form a hydrogen bond with a positively polarized hydrogen atom of water. Select hydrogens will be green here. So again, the hydrogen bonding, the atoms that can form a hydrogen bond are these hydrogens here. So this 1 here, 2, 3, and 4. So these 4 hydrogens here can form a hydrogen bond. And again, this says circle both O atom and 2 N atoms here. So these are all hydrogen bonding. This here, the oxygen here actually cannot hydrogen bond because again, I don't have a hydrogen here, right? This is a fully saturated bond here. So this is, so when they said circle O, it's actually not correct. Only the nitrogen atoms can actually hydrogen bond. And finally, this says here select, this here is the same question, no? Oh no, this is positively polarized hydrogen, and this is negatively polarized oxygen here. And this here is circle all 4 atoms here. So this here is 1, 2, 3, 4 because they get a hydrogen bond with this guy here, and this here is a positively polarized hydrogen atom of water, and in this case here it's circle both O atom and 2 nitrogen atoms here, which let's see, selected the atom. I don't know what they're asking here because I don't know if they're asking if it's which hydrogens can hydrogen bond, or let's see, select the atoms that can form a hydrogen bond with a positively polarized hydrogen atom of water. So it's O and the 2 N molecules here. Yeah, so this here is which atoms can actually hydrogen bond, and this here is which hydrogens are actually hydrogen bonding. So that's actually super confusing here. So let me explain this here. Okay. So this here is asking us which atoms can hydrogen bond, or sorry, yeah, which atoms can hydrogen bond here. And as you can see, I have, this is NH2, this here is H2N. And again here, which molecules can hydrogen bond? Well, I have, it's N, O, or F, right? So you can circle the 2 N's and the O's here. And then for F here, it's asking us double bond O, and this here is NH2. This here H2N, and it's asking us which atoms here are hydrogen bonding right now. And you can circle the 2 hydrogens here. So the solution here is correct. That was a very confusing last part of that question here. Good analysis. Super confusing there.